Hi, my name is Ruihan Xu, a CS undergrad in the Laboratory for Progress from University of Michigan. Along with my co-authors, we present single-view 3D reconstruction via SL2 Equivariant Gaussian sculpting network, which we call GSN. Consider a robot that wants to manipulate an object with just a single RGB observation. It requires an accurate 3D representation to perform a reliable grasp. While previous methods using point cloud and neural radiance field face trade-off between representation explicitity and visual quality, Gaussian splatting is a recent representation choice that leverages the advantages of both. So, we want a method that can take in a single image and produce a high-quality shape-completed splat, while leveraging Gaussian splat's explicitity to maintain output consistency when there is a perturbation such as rotation in the image space. Specifically, our model Gaussian sculpting network takes a single image through a CNN-based network, produces shape-completed 3D Gaussian splats, and multi-view rendering is used to train the network. In addition to image losses, to achieve equivariance, we introduce this new extended chamfer distance to ensure the shape-completed output remain equivalent under rotation in the input image space. Here is a qualitative result of our model evaluated on ShapeNet car and cherry dataset, highlighted in red. Our method outperforms NeRF methods and remain comparable with splatter image, which is another recent single-shot Gaussian splatting reconstruction method. In addition, we evaluate our model's equivariant awareness. A standard and a rotated RGB observation are fed through our model to produce two shape-completed Gaussian splat. After the two splats being transformed to a canonical orientation, they result in the same representation. Quantitatively, the result is consistent with the visual comparison, showing better PSNR, SSIM, and LPIPs against the NeRF baselines and comparable to splatter image. Our model gives a higher throughput, achieve 164 FPS, 3 times faster than splatter image. Additionally, our equivariant aware model produces a lower difference in 3D reconstruction after the image is rotated. We also applied our model in robot grasping application in simulation. Here, an RGB observation from a remote camera was fed through our model to generate a shape-completed Gaussian splat. Through the rendered top-down robot view, grasp is performed on the shape-completed part of the object. Here is an example of simulated grasp. Quantitatively, we evaluate the grasp quality using the remote camera with and without image rotation against the grasp quality when we have the ground truth top-down robot view. This demonstrates that our model is able to produce equivariant Gaussian splats with sufficient fidelity to permit grasp generation under image space rotation. Thanks for listening.